Hello everyone, I am Ankit Goyal, Professor and Head, Department of Mechanical Engineering, Technocrats Group of Institutes, Bhopal. Today, I am giving a short presentation on hybrid solar photovoltaic wind system for rural applications in India. The contents of these presentations are introduction, Indian scenario, renewable energy, hybrid energy system and design of hybrid systems. One of the primary need for social economic development in any nation is in the world is the provision of reliable electricity supply system. As we all know, energy is the ultimate factor responsible for both industrial and agricultural development. So, there is a need to develop an indigenous technology to harness the renewable energy to generate electricity. If we talk about the Indian scenario, we know that shortage of electric power is a serious problem in India. We see most urban and industrial centers in India are experiencing peak electricity shortage of over 15%. In India, several villages are still unelectrified. Government of India expects alternative energy sources such as wind energy and solar energy to play an important role in bridging electricity deficit in India. If we talk about the electrification in rural areas, providing electric power in rural area faces several problems. The most important in countries like India is the cost to install and serve the distribution line are considerably high for rural areas. In most of the rural and non-electrified sites, extension of utility grid lines experiences a number of problems. So, renewable energies are considered as to be a better option to meet these challenges. If we talk about the power scenario in India, the total power requirement of India, we see that total thermal power contributes the maximum part to the power requirement of India. In thermal, if we consider coal, it contributes about 58.9% in the power requirement. Gas contributes 7.6%, oil contributes only 0.3%. Hydropower is also a major source of supplying power requirement to India. It is about 13.5%. Nuclear contributes only 2.51% and renewable energy sources, these are solar, wind and other renewable, they all contribute to about 17.7% in the total power requirement of India. Now, what is renewable energy? Renewable energy systems are one of the most suitable and environmental friendly solutions to provide electricity within rural and remote areas. Advantages of renewable energies are gain and immediate access to reliable electricity. It provides to avoid long waits for grid extension, reduces the dependency from oil price fluctuations, increasing economic productivity, allows for a better use of local natural resources. Renewable energy. There are 5 main renewable energy sources. First is solar energy from the sun, geothermal energy from heat inside the earth, wind energy, biomass from plants, and hydropower from flowing water. To minimize the use of fossil fuel in all the sectors such as power, transport, industrial, agriculture and commercials, present session will focus on hybrid solar photovoltaic wind system for rural applications in India. This is a graphical presentation of solar photovoltaic system. In the generation of energy from solar radiation, the PV arrays traps the photon of sunlight and converts the light energy into electrical energy. As you see in our diagram, the sunlight from sun directly gets on the solar panel where they gets converted into electricity through photovoltaic cells or photovoltaic panel. These are transferred through inverter either for AC loads or may be supplied to grid connection through grid connectivity. This is an acceptable alternative means for rural electrification. Now, wind turbines. Wind turbines are used to generate electricity from kinetic energy of the wind. The generation of wind energy primarily depends on the wind speed. This is a graphical presentation of how wind energy is generated. Wind is basically air in motion. When wind blows, it rotates the blades of the turbine, which is a windmill, and it generates electrical energy through generator, which can be transferred to the grid through transformer to the main grid line, and which can be used for applications in power requirement. Hybrid energy system. Now, a hybrid energy system consists of two or more alternative energy sources. Hybrid energy systems are growing in popularity due to the improved reliability. If we depend only on one renewable energy like solar or wind, the reliability of system is not very effective, because if we talk about the solar energy, we get solar energy only during the daytime. Similarly, wind energy depends on the wind speed, which fluctuates during the day and night times. So, to make a system more reliable, we have to develop a hybrid system. The demand for alternative energy sources is increasing each year. So, hybrid energy systems are ideal for rural area applications. This is an experimental setup of solar and wind hybrid system. You can see in the given diagram the solar panels and wind turbine. Both are integrated to supply both DC load and AC load. The solar energy through solar panel, that is PV array, is used through solar charge controller to charge the battery bank. The same battery bank is also charged through wind controller using wind turbine. This battery bank is the most important part of a hybrid system, as it stores energy when there is a surplus of electricity generation, and it supplies back the energy when there is an energy shortage. This battery bank can be used to run the DC loads directly or can be used to run the AC loads using the inverter. The inverter which converts the DC load current into AC current is a part to run the AC power. If we talk about the solar resources, because we in hybrid system, if we are considering solar energy and wind energy, first we have to assess the solar resource of a particular site where we have to establish a hybrid system. So solar resource, that is photovoltaic system alone, if we talk, the daily solar radiation in India varies between 3.6 and 6 kilowatt hour per meter square per day. India lies near the equator and we have got a very good solar power resource in India. For this study, a location with latitude of 23.26 north and longitude of 77.41 degree has been selected, where the annual average solar radiation is about 5.67 kilowatt hour per meter square per day. If we see the total yearly solar resource available, we see during different months we get different solar radiations in India. In January, from January to December, if we see, we have got very good solar insolation during the period of January to June. July and August, which is the monsoon period, we get low solar insolation, and this is the overall variation in solar radiations throughout the year. This is a line diagram which shows how photovoltaic system, that is a standalone photovoltaic system, works. PV array traps the solar energy, converts it into electrical energy, which through charge controller can be used to run the DC load, or which can be stored in a battery bank, which through inverter can be used to run AC loads. DC power is the direct output of photovoltaic array, and this DC form power can be directly used with DC appliances. For AC appliances, this DC power has to be changed into AC form using power electronic inverters. Again, wind resources. Wind energy conversion system depends on the wind resource. If we have got a very good wind energy, the same system will develop more power, because the power generation from a given wind system will depend on the wind speed. In India, it is found that the average annual wind speed varies from 3 meter per second to 7.37 meter per second in India. For this study, we have selected the same location with latitude of 23.26 north and longitude 77.41 degree. The monthly average wind speed of the selected site is shown in the table. Again, this table shows the variation in wind speed from the month of January to December. We see that we got a very good wind speed, more than 3.7 during the month of April, May, June, July. So these are the months with good wind speed, and our wind system will work quite efficiently during this period. But if we see during the month of October, November and December, the wind speed variation is below 3. So the wind turbine system, the standalone system will not be very effective during these months. So there is a requirement of hybrid system. This is again a line diagram which shows wind energy conversion system. As wind blows, it rotates the turbine blade which converts the alternator converts the mechanical energy into electrical energy, which is stored in inverter or may be supplied to utility grids or power supply. The most important factor for the selection of wind turbine is wind speed. For wind speed calculation, the Webull's constant K, autocorrection factor, diurnal pattern, strength and hours of peak wind speed are the major requirements. These are the factors which are being considered while designing a wind system. Battery bank. As I have told you earlier that solar energy and wind energy does not give constant output throughout the day. So we require a battery bank which is used as a backup system, and it also maintains constant voltage across the load. Batteries are the main component of the PV wind hybrid system, which is used to store energy at time when there is a surplus of supply, which can be used to supply the load at time of more demand from the load. There are several battery systems available in the market, but lithium-ion batteries are used most prominently as they have got several advantages. Again, this is a line diagram of solar and wind hybrid systems. As we have seen in graphics, wind turbine uses the wind energy. Through controller, it can be used to charge the battery bank, which through inverter can be used to run AC loads. Solar photovoltaic PV array again are used through controller to charge the same battery bank, which through inverter is used to supply the AC loads. This is the design of hybrid system. The hybrid system consists of solar photovoltaic and wind turbine with the total power generation capacity is shown here. Wind turbine can be used directly for AC load or through converter can be used to charge the battery bank. Similarly, solar photovoltaic panel solar system is used to run the DC load, or it again through converter may be used to run the AC load. The system is designed in following steps. A small community is considered. The load demand is forecasted for a year by calculating electrical demand for each family, electrical demand for schools and hospitals, and electrical demand for irrigation and water supply. For a rural application, we consider a small village and we calculate the total power requirement of that particular village. In this, we consider different families living in that village. If there are some schools or hospitals, the load requirement of that particular schools and hospitals, and electricity demand for irrigation and water supply. Solar power analysis is done to find power output of solar PV on the basis of solar energy distribution at the site. This is used to calculate the number of panels required to produce the required power. Based on the above power output of solar PV and wind turbine, a solar PV wind hybrid system is designed. A storage battery bank using lithium-ion batteries is considered for short-term electrical power storage. The size of battery bank is worked out for 2 days. Lifetime of battery bank will be worked out This point is important while establishing the capital cost. To determine how many units of wind turbine and solar panel would be required, an analysis is carried out using the available wind data for measurement stations as well as solar data of the site. Wind power analysis will be done to find power output of wind turbine on the basis of wind energy distribution at the site. The AC power from the inverter of the system is fed to the distribution network of the community or may be used for rural irrigation and water supply to the community through pumped hydro storage system. Optimization will be done with the help of Homer software. Although there are many softwares available in the market, but Homer is considered a best optimization software if we consider solar wind hybrid system. The optimization model is a multi-objective and uses a controlled and list genetic algorithm to minimize the system configuration, LCC, that is life cycle cost, and maximize renewable reliability. The decisional variables are PV array, orientation angle, tilt and azimuth, PV array power peak, wind tower height, wind turbine rated power, and battery capacity. These are the different variables which we have to select to get different combinations so that we can optimize the output of a given hybrid system. Simulation and output analysis. Depending on the supply and demand, different operating modes can be defined. PV array and wind turbines partly supplying the load and partly charging the battery bank. Second, only PV array partly supplying the load and partly charging the battery. Only wind turbine partly supplying the load and partly charging the battery bank. We have seen that there is a variation in solar radiation as well as wind energy, wind speed during different months of the year from January to December. So depending upon the resource, if the solar resource is high, solar photovoltaic individual system can be used to supply the load, and if the wind speed is good, only wind energy system can be run to supply the load and to charge the battery. During some month when there is neither sufficient solar power, neither wind power, both can work simultaneously to supply the load and charge the battery. The simulation will be carried out using the Homer software. As I have told you, Homer is the best suitable software available for solar wind hybrid system. By running the software, the simulation results will be generated. Sensitivity variables such as wind speed and solar radiation will be defined as input into the software, and the optimization process will be carried out repeatedly for the sensitivity variables, and the result will be refined accordingly. Simulation results and output analysis. The simulation result of hybrid systems for optimal system design will be provided by Homer. Homer is a hybrid optimization model for electrical renewables according to the sensitivity analysis. The Homer software determines optimal cost and sensitivity analysis of the proposed system. Expected outcome. Expected outcome are as follows. Design optimization of wind and photovoltaic generator ensures low operational cost and therefore is considered as an important issue as there is a strong need to switch over from conventional to renewable source of energy. An approach for sizing along with a best management technique for PV wind hybrid system with batteries is proposed in the work. The annual hourly values for wind speed and solar radiation for Bhopal will be used in the design of the system to compensate power requirement. A hybrid power model is also developed to anticipate performance for the different system according to the global warming. So, we see that developing a hybrid system of solar and wind to get sustainable power throughout a year is the best system in Indian scenario because these are best suited for rural electrification, irrigation and water supply through pumped hydro storage. India has got a very good solar resource. Our Prime Minister is also focusing on the use and development of renewable energy system like solar and wind to make up the deficit of electricity in India. I hope this presentation will help you, or this presentation has given you an elementary idea of solar and wind hybrid system. Thank you very much.